Hello there. Today we'll be doing number 41, longest repeating character replacement. Alright, let's see. This particular problem gives us a string and an integer k, and we're going to choose a character where we can replace the k at most times and get a particular, the longest length. And so in this particular case, we have AB, and we replace the two B's with two A's. In this case here, replace the one A with to get the four B's, or replace the one B to get four A's, one or the other. So we just want to know how we can get the longest repeating character with replacement. So this is going to be a sliding window problem. Basically, what we're going to do is that we're going to store in a dictionary for our characters to see which one's the longest character, and using that we can subtract that against the current length of our string, and because we can do that, we can what will happen is that we can make sure that that the replacements are enough to handle our replacements, and if it is not, then we'll replace the scene character with another, and then we can increment the sliding window from the left side until we get to the point where we can the length of the characters minus the most frequent item that we have is less than k, and then we can check how long that is. I think there are going to be some optimizations that will be done here. Let's just start. So we'll start with default dictionary. This is a wonderful data type that allows us to add items without even having to have a default value. We're gonna get our longest string here. We'll start at 0, and let's set our max frequency. That is the most frequent item in our particular length of the list. We can also, knowing that the length will not, if the max frequency does not change, we will not be changing our answer. Everything else is going to remain the absolute same, even as we add more items to our particular length of the string. We're still going to be completely fine, because, well, yeah, it's gonna be completely fine, because, well, we don't need to handle like, yeah, I'm not sure. Let me go check on that. So anyways, we start at length of 0, and for R in range length of S, we can move forward into our sliding window, and S of R is going to be our first character, and plus equals 1. So now we can check our max frequency, which is equal to max of max frequency, and the scene item, our current scene item, because that's the only way we can get a new max frequency, is as we're adding. So while the length of our string minus the max frequency, the item that we have most frequently, is greater than k. If it is ever greater than k, then we can remove our item L minus 1 minus equals 1, and L plus equals 1. So that shrinks our string so that the items that are most frequent can exist inside the string. The thing is, I'm worried, is that the longest, as we increase the range of the string and we don't get the same frequency, would that change anything? Well, I would say as we increase the range, we would be limited by k, and it doesn't change anything because we max out our range based on that particular frequency, our r minus l plus 1. So our longest string will be limited by our max frequency the entire time. So that must mean there can be optimization there. There is. But let's return the longest here first, and then we'll make the optimizations. Let's run it. Oh, okay, that's fine. Let's see. Longest string. Run. Looks like I'm getting pretty tired, but that's okay. With number of videos I'm making every day. So let's see. Right, the optimization is because we're limited by this max frequency minus this particular length. This max frequency plus k is going to be our longest string. So we don't even really need this longest string. That's the optimization here. We don't need that. We're just gonna take the max frequency plus k. Yeah, I don't know if that's possible. Yeah. Let's run it. I don't think it's gonna work. Oh no, let's run it. Yeah, it's not gonna work. Because we're gonna have the extra k going on. Or the min of the length of string. Run. I don't know, it might work, it might not work, I'm not sure. Okay, let's try A, B, A, A. Okay. What if max frequency plus 2 is greater than the length of string? So let's try that. Run the code. I don't think that'll work. What's going on here? This is weird. I don't think it'll work though. What? Yeah, weird. Okay, well, looks like we solved it in a very creative manner, and we found an even faster solution. Great. That is certainly interesting. I was looking for a way of getting the max frequency plus k to be more than that of the length of the string. It looks like that isn't possible. That was the only edge case. And we were able to get a very interesting solution here. But what we learned today is a sliding window technique. Need some water. Okay. So it's a sliding window technique where we move the window forward until the point where we needed to swap to move the left side of the window, and that point is at which the max frequency plus k is less than the length of the string. And so with that, we needed to shorten the string so that we can continue to comply with that particular order mandate. And so that is exactly what we did. We moved the left side of the window so that the number of the most frequent item plus k is going to be less, so that it's going to be within the length of the window is going to be small enough to make sure that we can satisfy the k condition. Hopefully that makes a lot of sense. If not, you can comment below, ask some questions. If you enjoyed the video, like and subscribe, and if you want more videos, check the link in the description below. Yeah, and I'll see you in the next one.